Hello mathematicians and welcome to day one of Trig. Before we start off, please make sure you have this green sheet in front of you. We're going to be using it this whole unit and you're going to be taking notes on this one sheet. Put it somewhere safe. And you're also going to need the day one worksheet, which is Pythagorean's theorem. So you have those in front of you. Let's start off. So Trig talks a lot about triangles all over again. Geometry loves triangles. A lot of shapes are made up of triangles. And it's all about different methods we can use to find the sides and the angles of certain triangles. So for today, we're going to start off with Pythagorean's theorem. So a lot of you guys have already been exposed to this, but I'm still going to give a short review on it. So in order to use Pythagorean theorem, we need two things. The first thing is that we need a right triangle. This theorem does not work for any triangle. Okay, it has to be a right triangle. And the second thing is that we need to already know at least two sides. So their lengths. So right here, I drew a little triangle for you guys. And remember that we have a way in which we denote what a right triangle is. And it is this box. Now, for Pythagorean's theorem, they use certain vocabulary to speak about the different sides, okay? The first one is the hypotenuse. The hypotenuse is always going to be the one that is opposite to our right angle, okay? The second term we have is a leg. So this side is going to be a leg. And this bottom side is also a leg. So in the case that we have here, only the hypotenuse is special. Everything else is just a plain old leg. Now for the equation, we don't write out all of these. Instead, we use variables, okay? So typically, we call this leg side A, the other leg side B. Now, it does not matter if this is side A or this is side B. You can interchange them as long as we keep that side C as the hypotenuse. C is always the hypotenuse. Now, there's an equation that ties in all of these sides together, and that is that A squared plus B squared equals C squared. Now, this next part, don't draw this, but basically this formula is saying is that if I were to make a square on this side and on this side, and I were to add up all of its space, that space would be the exact same as this square, okay? And that's how we get the formula. So we're going to be using this formula to solve different problems. So now I'm going to switch over to the worksheet, okay? I have two examples here. So I'm going to do the first one. Find the hypotenuse of a right triangle. This is really important. Right triangle. Given that the length of one leg equals to 3 and the length of the second leg equals to 4. The fact that they said a right triangle is really important because this gives me permission to use Pythagorean's theorem. So in math, I always highly recommend that we do drawings when we have word problems because word problems can be very overwhelming. So I'm going to draw a right triangle. So it says find the hypotenuse. So that hypotenuse is going to be our x, right? We're going to use that as a variable. Given that the length of one leg equals to 3. Now again, the legs can be used interchangeably. So you can write 3 right here, or you can put it at the bottom. It doesn't matter. And the other leg, and the length of the second leg is 4. So I have 4 here. So again, since I have a right triangle and I'm given two sides, I can use Pythagorean's theorem. So remember, it is A squared plus B squared equals C squared. So that's the equation I'm using. Now for the math part, I'm going to just plug in my values. So my A is 3 squared Well, let me write this a little smaller. 3 squared plus 4 squared equals c squared. So now I'm going to simplify. 3 squared is 3 times 3. It is not 3 times 2. 3 times 3 is 9 plus 4 squared. 4 times 4 is 16 equals c squared. Now I'm going to add. So 9 plus 16 is 25. And that is c squared. So is my c by itself? Nope, it is not. I have to still get it by itself. Now the way I can get it by itself is I have to get rid of the squared. The opposite of a squared is a square root. So if I square root that, this 2 will cancel out the square root. But what I do to one side, I have to do to the other side. So I get that c is equal to the square root of 25. So what two numbers multiply together is 25? Or you can use a calculator. I really like the Google calculator. So I'm going to do square root 25 and I get 5. So my answer is 5 and I'm going to write it right over here. Cool. Now let's do the second one. Find the length of a right triangle. So right triangle. If its hypotenuse has a length of 10 and the other leg has a length of 6. So again, I'm going to make my drawing. Oh, I didn't make it long enough. Close enough. Since it's a right triangle, I'm going to put my little sign that this is a right triangle. And it says the hypotenuse has a length of 10. So 10 right here. And the other leg has a length of 6. So I'm just going to put 6 right here. So again, since I have a right triangle and two sides, I get to use Pythagorean's theorem. Why is it called that? Well, because there was a dude actually named Pythagorean. So it's saying like Miss Torres's theorem, Pythagorean's idea. So we come up with a cool theorem, you get your name on it. Anyways, so now let's plug in our values. So I have c squared plus b squared equals 10 squared. So now we actually have a number on the other side of the equal sign. So I'm going to simplify now. 6 squared is 36. B squared remains the same. Now 10 squared is 100. So now here, this is when our problem is different from the one before. Our variable is not already isolated. We have to take a couple of extra steps. First off, I have 36. I want to get rid of it. Since it's adding, I'm going to do the opposite and subtract. And what I do to one side, I do to the other side. So I get b squared equals 64. And now I have to square root it in order to get rid of the square. And what I do to one side, I do to the other side. So I have b equals to the square root of 64. Oh, 64. And I get 8. So my answer is 8. So how are these two problems different? Well, in the first one, we were given, case 1, we were given legs and had to find hypotenuse. Well, we had to just find the hypotenuse since c is already on the other side. All we had to do is take the square root and we were done. But in case 2, we were given a leg and a hypotenuse. And we had to find the other leg. So since we had to find the other leg, we had to move either A or B to the other side. subtract, and then we had to take the radical. So it's a little bit of a longer step. So here you go. These are the two types of problems that you're going to encounter. So go ahead and jump out to Delta Math, and I'll see you for the next video.